Hi, I'm Russinovich, Chief Technology Officer and Technical Fellow of Microsoft Azure. And what I'm going to talk to you about is a major step forward in confidential computing that we've taken together with our partner, NVIDIA. We're realizing together a vision of confidential AI. Now, first, what is confidential computing? Those of you familiar with computer security know that we try to protect data throughout its entire lifecycle, and we do that through encryption. When we store data on media like a disk, we encrypt it, and this is called encryption at rest. And that protects the data from anybody that has physical access to the media or logical access to that disk without going through the application. If they try to read the data, it's encrypted and not in clear. We do the same thing with data when we send it between two different servers. We encrypt it on the wire, and that means that somebody that is sniffing the network just sees the encrypted data and not the clear text data. What's been missing up until now is protecting that data in the third pillar of its lifecycle, which is while it's in use. When the CPU loads that encrypted data from disk or gets that encrypted data off the network, it must decrypt it to process it. And at that point, it's vulnerable, it's in the clear. And that means that the hypervisor might be able to have access to it. The operating system that the code is running on might have access to it. Admins servicing the virtual machine or the server might have access to it. And physical personnel doing maintenance on the server might be able to get access to it. Confidential computing completes that third pillar of protection by creating a trusted execution environment, or TEE, that surrounds the code and the data that is processing that data. When the TEE is created, it's loaded with code. That code then can get an attestation report from the hardware, from the CPU, present it to somebody external, a remote party, through something called remote attestation. That remote party can verify that attestation report, make sure that the code is the code that it trusts and that it's being protected in a TEE by hardware that it trusts, and at that point, release a key that encrypts to that TEE that allows that code then to decrypt the data that it might read off disk or read from the network and perform processing on it. Now, it's in the clear inside that TEE, but because it's inside the TEE, it's protected from the hypervisor, from the host operating system, from the admin of the server, and from physical access as well. This major step forward we're taking with NVIDIA is to introduce confidential GPUs. Working deeply with them, we've co-designed the Hopper H100 confidential computing GPU. This GPU creates a trusted execution environment such that the model of an AI model will be protected inside that trusted execution environment, and so will the data that that model processes. In combination with the confidential CPU, that allows us to have confidential AI, where the data might be loaded into a CPU, decrypted inside that CPU TEE, sent over to the GPU, where it is also then decrypting that data that the CPU encrypted as it hands it to it, and then performing computation on it. That protects the data through its entire life cycle in an AI scenario. And the AI scenarios that confidential computing protect include protecting the model itself. A lot of these models that are being created these days have IP inherent in them. They must be protected from unauthorized access and usage. Confidential computing with the Hopper GPUs protects those models from outside access. It also protects the data that those models have access to. And there's a few different ways that models use data. One of them is in the training of the model itself, in that pre-training phase where the model is processing data as it learns that data. With confidential computing, that data can now be protected through that pre-training phase, and that data might have very sensitive information in it that others shouldn't have access to. Another type of data that can be protected with confidential computing is fine-tuning data, where you take a pre-trained model and then continue some training on it with custom data that is for a particular scenario. This is common for enterprises, for example, where they're bringing their own private data and having a model learn the specifics of their own data. That data can be very sensitive, and so it can be protected through that fine-tuning process with confidential computing. And then a third type of data that AI models process are the prompts and the responses that they generate. For example, when you send a query into a large language model, that's called the prompt, and you want that protected maybe because it has very sensitive information in it. Similarly, as the model processes that data and it generates a response, that might also have sensitive data in it. With confidential GPUs, you can protect that data all the way from its origination into the processing and the response on the way back. A third scenario for confidential AI that's really exciting is the confidential multi-party AI scenario. That's where multiple parties each have their own data sets that through regulatory reasons or maybe data privacy reasons might not be able to share with one another. But combining them, they might get really deep insights they can't on their own. Confidential multi-party AI allows them to combine their data by trusting only to TEE and the code that has access to that data, and then they can get the insights back from that data. And maybe not all of them are allowed to get the insights, maybe only one of them is. The scenarios in verticals are endless. For example, in healthcare, where you've got different parties that have their own health data sets they want to combine to get deep insights from it, is just one scenario. In the financial sector, having auditors looking for fraud that might combine data sets they have access to with the transaction data sets that a financial entity might have is another example. And the list goes on and on. Now, what I'm going to do to demonstrate in concrete terms what confidential AI looks like is with a scenario that we call retrieval-augmented generation. I mentioned fine-tuning a little bit earlier, where you take a pre-trained model and then you have it learn about a custom data set, an enterprise data set. But a more common scenario for having a model know about custom data is retrieval-augmented generation. In retrieval-augmented generation, or RAG, you take your data set, you chunk it up, and you create vectors that are embeddings of those particular chunks. And you store those embeddings in a database. What that allows you to do is to later take a query, create an embedding of that query, and then do a nearest search in that database to find relevant snippets of code or text or documents. Pull that out and then hand that relevant information as part of the prompt to the large language model. And that allows it to go reason over that relevant information and provide a response that is very tailored towards that custom data with the insights that the large language model provides. In the demo setup I've got a web browser that is going to connect to a service. That service is running in a confidential virtual machine that is connected to a confidential H100 GPU. That confidential virtual machine has a vector database as part of it, and that's going to allow us to do retrieval-augmented generation on a document that we upload. Through the entire process I'm going to show you, my data is going to be protected end-to-end. So let's go take a look at that demo. Now here you can see I've got the website. It's the first time that I visited that website, and so my extension that is enlightened to understand attestations from the CPU and GPU realizes that we don't have a policy set for that site. Now, in a real scenario, the enterprise administrators would have configured my extension to know that site with the policy. But here what I'm going to do is add that site to my trusted websites by authorizing a policy that matches the attestations. And those attestations include the CPU versions, the TEE versions, the firmware, the software that's running in the confidential virtual machine, as well as the same for the H100 GPU, including its driver, firmware, information. Now that I've got a trusted policy set up, I'm going to go and send in a prompt. This prompt is going to be encrypted on my end, sent in encrypted form into that confidential virtual machine, given to the confidential GPU. That confidential GPU is going to perform inference on it and provide a response. In this case, I've asked it what confidential computing is. In this particular model that I've got running inside the GPU, it's not familiar with that term. This is where the power of retrieval-augmented, or RAG, is going to come in. I'm going to upload a PDF that includes information about confidential computing. That document's going to be chunked, vectorized with embeddings, and then that database is going to be augmented. And now when I enter the prompt again, the large language model is going to be given the relevant snippets of text from that document, and it's able to provide an accurate answer to my question. The process of uploading that document was protected end-to-end with confidential computing. The vectorization was protected. That database is protected. That data that it might be very sensitive is not accessible to anything but the confidential virtual machine and the GPU. Now I'm going to do one last thing, and that is to go to my policy and change the driver version for the GPU. That's going to mean that when I go visit that website and it gets an attestation, the browser extension is going to see that it's not matching the policy that I've set. And it's going to show me with this warning in red here that I should not trust the website given the policy I've got configured. That's going to prevent me from inadvertently submitting prompts or uploading documents for RAG processing that might have sensitive data, but then at that point might be available to others that are unauthorized because it's not being protected in the way that I want with confidential computing. So I've shared with you a major milestone in the journey that Microsoft Azure's on towards ubiquitous confidential computing, filling in a missing piece with the introduction of confidential GPUs in deep partnership with NVIDIA. I recommend you check out our confidential GPU offering, as well as the other confidential computing offerings on Microsoft Azure. Thank you.